So hello everyone. Today's question of 3rd April is a word search, right? And this question has been asked in Amazon 36 times and Twitter 23 times. The question being marked as medium, although it's of a great question of recursion. So let's see what the question states. You are given an m cross n grid of character board and string word. Return true if the word exists in the grid. Okay, the word can be constructed from the letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring, right? And the same letter may not be used more than once. For example, this is a case, right? So what we're gonna do is see the first board is given here and the word is A B C C E D. So first you will traverse from A, then you will go to B, then you find again, then go to C, then come down to C, E and D. So the whole word exists here, right? So it will, that's why it will return true. Let's see the false one. So A B C B. So A B C, you can go till here, right? But after this you cannot go anywhere and find B sequentially after that, right? You can find C, you can find E, you can find F, again E, but not the A B C B. That's why it will return a false. So what's the approach, what we're gonna do? So first we will traverse in the whole matrix and find the first letter of the word, that is, for example, in this A, we'll first find A is present at which place, right? So as soon as we find A, we will start the recursion from this place. So as we found A, we'll start checking from the for the next letter, that is B. So we will traverse in the down direction, right direction, left direction and up direction. In all directions we will check and see if B is present or not. If B is present, then again recursion will be called and we will find for C. Again, if C, for C, B, all directions will be moved in all directions and we will check if the element is present or not, right? So the next element which comes is again C. We have checked for C, then again C will check for all directions and it won't find it will find a letter C again, right? So again C will move in all directions and find E and D. So I will do a dry run for the code and it's not a big deal. So let's first let's see this example. So let's see this example, right? Let's say the word is A, B, C, and again let's see, take C, right? This is the word we need to search in this matrix, right? So first we will check the first letter is present or not. The first letter is here. By chance, if it might not been here, let's say it would have been here, then we will start from this place, right? So first we'll check for the first letter wherever it comes in the matrix. So in this case A comes here, so we'll start from the recursion from this place. Then we will check A, then it goes to B, right? It will check, it can go in all direction, this way, right? This way it will check, and as soon as it gets B, that is the second letter of the word, then it will move again to this place. Again it will check in all directions and find the next letter C, right? So C will be found in the right side of this B. As soon as it's found C, this again will move in all directions to find again the letter C, and as soon as it get a C, it will come out of the word index, and it will be our base case that if the word ends, then you need to return a true for sure, right? Return a true. Okay, so let's see the example, this only, like A, B, let's say C and D is given, and E, F, G, H, this is the matrix, right? And the word which you have to find is B, E, C, H, right? Let's take this word, right? So first it will find the first letter B, so it will keep moving, and it found the B. Then it will move in all direction to find E, but it won't be able to find E in any direction, right? So it will return a false and move to other letters which are remaining in the whole matrix, right? It will check for C, again it will find the first letter only. Its main maksad is to find the first letter B, and after that it should be sequentially, right? It can't be right you found a b here, then use break the loop again and go to all other directions which are possible. You should move to the next pointer e sequentially, right? Then it will be searched again in the whole matrix, right? So it will be searched and nowhere it will find a b, so that's why after ending it, it will return nothing, no true. So at end it will return a false statement, as we will see in the code. So I hope the approach is pretty much clear. So let's see the code now, right? So what are we thinking of? Okay, so first, this is our main function exists. We will create an n and m matrix, that is both size, right? The n cross m matrix which is given to us, and we will start traversing in the whole matrix int I equal to 0 to I less than n and I plus plus, and j equal to 0 to j less than m I j plus plus. Now if the board of I j, that is the first letter, the board, and we are checking the word 0, so if it is found like b is found here, right? So as soon as b is found, we will start our recursion path, right? Then we will check if solve of whatever we passing, I will also define it. 0 word board I j and visited. Board is pretty much clear. Visited is an array which we are creating, so that if one element is visited once, it should not go back. For example, a b c, then C. Now you should not be going to C again, right? If you are going to C again, then it will be an infinite loop. So C, you go to C again, you go to back to C, then again you come back to C. So it will be an infinite thing. So you are taking a visited array for this case, right? So visited, and 0 is the index, which is, for example, word of 0 is here, so you will pass a 0 for it, and the word itself you will pass, and if it returns a true, the whole loop, then you will return a true. So let's see now the solve function. The solve function, here we are passing index, word, the board itself, and the row, column, and the visited array, right? So we'll create an m, and again we could have passed it also, but we have defined it again, and t is the word of size. So if indices is equal to t, that means you have reached the point where the word is finished, and you can for sure return a true, right? At the last index, after finding the last index, when you move out of the index, there is nothing to check, and if you have checked till this place, that means for sure you have found the word and you should return a true, right? And then you will check the cases, edge cases, that if the row is less than 0 or the row is greater than equal to n, that means you are out of bound, right? Your array, for example, in this place, if you are searching for let's see, in this case, right, you are searching, you cannot find the letter before a, right? At this place you can't find, right? At this place you should not be finding any letter. That's why it is the edge case. Row should not be less than 0, row should be greater than equal to n, same for column. And one more thing, the letter which you are searching should not be visited, right? If it's visited, then you should return a false, right? So you should return a false. And the last is board of row is not equal to, means what you are searching. For example, you are searching at this place, you are searching C right? You go down and you found a F. So if you found a F, you should return a false in that case, right? And we should also mark the row and column as true. Visited of row and column is true, so that we should not go back to that row and column again. Now you will check the four directions which are possible, that is left, right, left, up, then right, and then down. Now there is a one very famous method in which we create a vector dr and dc, and we check all the elements, like for example, if you go upward with what, row will become a -1 and column is same, so -1 0, and then this side when you come, row is still 0 and column is +1. When you come down, row is +1 and column is +1 and column is 0, and when you come back this side, this row is 0 and column is -1. So generally we create a vector dr and dc, and then run a for loop for 0 to 4 times, 3 times, 0 to 4, and we insert all those elements inside that. But in this case, that part is failing, so we should definitely try the individual times we should write it. So for solve index plus 1, that is for sure that if index 0 is checked, you don't need to check that index again. So you will solve from the index plus 1. Word will be given to you, board is given to you, need to check for row. So for example, see, row plus 1 you are checking, row plus 1, so column should be 0, right? Then you check for row minus 1 and column. Row minus 1 and column means row minus 1 and column should again be 0. Then you are checking for row and column plus 1. Row and column plus 1 means row should be 0 and column is plus 1, for you are checking for this one. And at the end you are checking for row and column minus 1. Row is 0 and column is minus 1. So all these cases you are checking, and if any cases gets you the desired result, that is recursion will call again start solving these values. If these values will be solved, and if it gets a true, then it will return a true, right? And at the end you will do what? You will do a backtracking. That means you might have get a, yes, for example, you might get a b in the path, but after that you should for sure make it. So let's quickly discuss the time complexity of this code, right? So the time complexity is pretty simple. First, we are traversing in this whole matrix, so it will be O of n into m, and after that we are calling a recursion stack, right? So recursion will take a time of every element, every word will be searched for, will be searched in all four directions, that is 4k power k, right? So total time complexity will be what? O of n into m, that is for the loop, into 4k power k, right? 4 to the power k. This will be the total time complexity. And the space complexity is, we are creating an n cross n vector, so it will be the space complexity and some recursion stack, right? So this is it for this question, word search, right? It's marked as medium, but it's one of the good question of recursion for sure. So I hope you liked the video. If you liked it, you can subscribe and ask any doubts in the comment section for sure. So thank you for watching.